Hey there, in this video we're going to look at quadratic functions and specifically the key characteristics of a graph of a quadratic. So remember, when we look at an equation in standard form, we know it's quadratic if the highest exponent in that standard form equation is 2. In other words, if it's a degree 2. So if we have a degree 2 polynomial, we are going to have a parabola shape. So the parabola will be the shape that we see, and again, that is just a U shape. So it will either be opening up or it will be opening down. It opens up if the arrows are pointing upward, or it opens down if the arrows are pointing downward, if there were arrows on the end. Sometimes we see graphs where it's just the U shape and no arrows shown, but where those ends essentially point is whether it's opening up or opening down. You will not see it open sideways either direction. You won't see it open like diagonally or anything like that. It will always be up or down. So let's take a look at a parabola and let's talk about some of those key features. So the first one we're going to talk about is whether this opens up or down. So again, think of where those arrows are pointing. On this one, they are pointing up. So this parabola opens up. Next, we look at the vertex. So the vertex is always going to be the highest or the lowest point on the parabola, depending if it opens up or if it opens down. If it opens up, the vertex is down here on the bottom. If it opens down, then the vertex is up here on the top. So with this one, it opens up, so our vertex is going to be that lowest point down here. And so that ordered pair would be 2, -2. So ordered pair from the origin, we go right 2, down 2, so this is 2, -2. Then we look at our x-intercept, and remember, our x-intercept could actually be multiple, and we'll talk about that in a minute, but the x-intercept is going to be any point where it crosses the x-axis. That's going to be your x-intercept. So for this one, we see this point right here and this point right here are both places where the graph, the parabola, crosses the x-axis, and so those as ordered pairs would be 1, 0, and 3, 0. So those are our two x-intercepts on this graph. Our y-intercept is going to be wherever the graph crosses the y-axis, so same concept. We see this one point here. If it's a function, which if it's quadratic it will be, if it's a function it's only going to have one y-intercept. Otherwise it would not pass the vertical line test and wouldn't be a function. So if it is quadratic, it will only have one y-intercept. So here we see this point right here is our y-intercept. So as an ordered pair, that's going to be 0, up 6. So 0, 6 as our ordered pair of our y-intercept. And then finally, the axis of symmetry is the vertical line that divides a parabola into two symmetric reflected halves. Typically, it's drawn as a dashed line, and it is always going to go through the vertex. So that is your axis of symmetry, AOS for axis of symmetry, and that is always written as an equation x equals, and then whatever number it runs through on the x-axis. In other words, whatever number is the x-coordinate of the vertex. So x equals 2 is the equation of the axis of symmetry. Now let's talk a little bit more about x-intercepts. So x-intercepts have many names. So it could be an x-intercept, it could be a root, it could be a solution, and sometimes even called a 0. So those 4 names are typically interchangeable, and so any of those can be used to refer to the point or points where the graph crosses the x-axis. So if we see solutions, for example, visually on a graph, that's where it crosses the x-axis. So on these 3 graphs, I show you 3 different examples to show you that a parabola could have 0 solutions, it could have 1 solution, or it could have 2, depending on where that parabola is located. So for example, this first one on the left here, we see that this does not cross the x-axis. So if it does not cross the x-axis, that means it has 0 solutions. And again, that's because it doesn't cross this x-axis at all. And if it were to continue where the arrows are pointing, it still will never come down here to hit the x-axis. The second example has the vertex here on the x-axis, but it will never come back and hit that again because it will continue to go up here and here. So if that's the case, then that is just one solution, or in other words, one x-intercept. And then finally, we could have a parabola where it crosses the x-axis twice. So this would be an example of that, and that would be two solutions. So again, it just depends what the graph looks like, and don't forget that it could open down. So these aren't the only three scenarios. For example, I could have a zero solution one where it is a parabola that opens down below the x-axis, and that's not going to cross. So that would be another example of zero solutions. Or one solution, I could have something that opens down and its vertex is on the x-axis. That would still be one solution, just a different visual. And then same concept here, I could have a parabola where it's opening down but still crosses the x-axis twice, and that would be another example of two solutions. So I just want to make sure it's clear that there's not just these three printed examples on there. It could differ and vary quite a bit. It's just going to fall into the category of 0, 1, or 2 solutions if it is in fact a parabola. So in summary, we have some key characteristics that we like to look at. The first one, again, is that opening up or down. The second one is the vertex. The third one is the intercepts. So that's the x and the y-intercepts. X being where it crosses the x-axis and y where it crosses the y-axis. And then our axis of symmetry running down the center of any parabola. All right, and finally, the number of solutions. Remember, we talked about there's either going to be 0, 1, or 2 solutions to a parabola, meaning the place or places where the graph crosses the x-axis, or in the 0 solutions scenario where it doesn't cross at all.